Okay. Someone asked, like, which is better, astronomy or meteorology, and I don't know. I think they're both great. This whole class is kind of about giving you some things to learn, like memorize, some kind of concepts to get under your belt, and then some kind of vocabulary along the way. So that definitely is kind of what we're going to do here in astronomy. I think astronomy is a beautiful science. Astronomy is not the same thing as astrology. Astrology is like the whole horoscope thing, and that has to do with stars, but astrology is not a science. Somebody said, well, why didn't they call astronomy astrology, right? Because the word astrology was already taken, is what I think. So one of the things I want to do right off the bat, we'll get to the whole stars and all that, but I want to kind of make sure we're all kind of oriented with regard to the Earth and the Sun and kind of even the Moon, okay? But of course, the Earth orbits the Sun, okay? And our Sun, we'll talk about stars, but our Sun is just like a typical star, okay? And what we know is that most stars have planets that orbit them, okay? Our Sun has, 8 planets? Okay, Pluto's not a planet anymore. Okay, so our Sun has a set of planets that orbit it, and the Earth is the third rock from the Sun. Final answer, third rock from the Sun. So all of the planets, including the Earth, actually are kind of bound to the Sun because of gravity. So what works pretty good in this class is if I make this the Sun, okay, so this is the Sun, okay, and so the Earth orbits the Sun. I brought my Earth here, and it's all about gravity. And just to kind of remind you that we talked about gravity in the physics chapter. We said that, let's see if we can kind of pull that up. We said, and you guys had this on your test, gravity, okay, force of gravity is equal to, whoops, let's do that different. F sub g, final answer, is equal to the gravitational constant times the masses of the two objects that are interacting divided by the distance between those two objects squared. Okay, so we kind of talked about how the force of gravity is stronger, obviously, the more massive the object. The Sun, oh my gosh, it's like very massive compared to the planets. So a few things here. Okay, so the Earth orbits the Sun. The Earth orbits the Sun. And to me, I get my orbit and my rotation mixed up, so the Earth also spins on its axis. We call that rotation. Sometimes orbit, they'll call it revolution, which kind of drives me nuts. Okay, but this is the Earth, and it goes about the Sun once every year. So for us, and each planet is a little different, it takes us 365 days to do this one time. Okay, so we do that. Now, a few things, again, kind of terminology. Can you see how when I went around the Sun, I kind of made out it's almost like you guys don't know records anymore, but you guys do know CDs, right? So it's nice flat, like CD. It's a plane, what we call a plane. This actually is what we call the plane of the ecliptic. This thing, this kind of path that holds this sheet of paper or whatever that holds the path of the Earth as the Earth orbits the Sun is called the plane of the ecliptic. When we talk about other planets, all of the other planets pretty much also are on that same sheet of paper. So it's kind of nice. It's called the plane of the ecliptic. Let's see, what else? I guess before I go on, actually it's thinking to go on, but this little picture down here refers to something called the International Space Station. So the ISS, International Space Station. Has anybody in here seen the International Space Station pass overhead? I'll try to there's a website that you can go, and I'll tell you what the website is. Okay, so this has to do with the ISS. ISS stands for International Space Station. I emphasize the word international because all nations contribute to its maintenance. We have astronauts up there in space, in the space station, of different nationalities. We had a speaker come and speak last Thursday. He was a NASA guy, and it was neat to hear him talk about kind of the collegiality with regard to the space programs of the different nations. So anyway, the International Space Station, if you want to know when to see it, you go to this website, and then I think it must be a dash above .com, heavens-above.com. And what that will give you is pass information, pass info for the International Space Station. So I'll try to kind of keep an eye out and let you know where to look in the nighttime sky if you want to see that. And it just goes like this, kind of just has that sort of, and it just, you'll like it. What else do we need to know? Okay, so the Earth orbits the sun, okay, in a year, 365.25 days. The Earth also spins on its axis of rotation. So here we go. Here's our Earth, okay, and of course it spins like this. It's really kind of spinning kind of fast. It seems like to me, okay. But you figure if that's the sun, and it works pretty good if I make see this plastic right here, we could make this our daytime boundary, okay. So here we go. Let's see, where are we? North America, right there, okay. So here, like we're here, kind of in Midwest. That would be like noon, wouldn't it? Because there's the sun. Okay? And it's all about counterclockwise. Ooh, darn it. Okay. This is the counterclockwise. We obviously have digital clocks anymore, but if you think of the kind of the regular clock, counterclockwise is this. All right. So here we go. Counterclockwise. Looking down at the North Pole. So here we go. Does it look like it's going counterclockwise now? So here, that would be like noon, okay, and this would be like kind of dusk. Does that seem right? Because the sun's setting, okay. We're here in North America, and this would be like nighttime, right? And this would be like maybe midnight, okay. And this would be like okay. This would be like dawn, okay. It's dawn, okay. So it does that once every. I have a little video to kind of show you, hopefully. Will play for us. One thing while I'm thinking of it, and this isn't in my notes, but have you ever heard that the Earth used to spin faster? Okay, it did. It's been slowing down. The Earth day now is 24 hours for it to go around once, to spin once on its axis. It used to spin a lot faster, then it slowed down over time. Okay, so you see the word ecliptic up there again. Ecliptic is that sheet of paper, basically, that contains the Earth's orbit as it goes around the sun. All the planets are kind of on the plane of the ecliptic. The other thing, and this is an important thing, we'll kind of kick around a little bit, but can you see, like, when you buy a globe, okay, like, the axis, like this is the North Pole, right? And this is the South Pole. And they're like offset from being directly like that, okay? That's because, and I brought this here today to kind of be the Earth's axis of rotation. So when you buy a globe, it doesn't like spin like this, the counterclockwise, okay? It actually goes like this. And early on, okay, when the planets formed, what made most sense, like physics and stuff, would be that they'd be like this. And when I say that, what I mean is, okay, here's the axis of rotation, and here I go orbiting the sun. Okay, and I'm about counterclockwise. Okay, good. I'm going counterclockwise. Okay, this is what planets should do. And early on in the formation of the sun and the planets, actually, there was a lot of kind of miscellaneous stuff, very chaotic. And so the Earth got hit by an object about the size of Mars, the planet of Mars, and it got tilted like that. And actually, we think that same strike helped create the moon. Some of the material of the Earth kind of was flung into outer space and began orbiting the Earth, and became our moon. Is that not just poetic or what? Okay, so the Earth's axis of rotation has been tilted ever since. Okay, so the tilt actually has an angle, and it's 23.5 degrees. So it's 23.5 degrees from what, right? From being perpendicular. So like this would be, when perpendicular is what I call like a right angle or a 90-degree angle. That's straight up and down. 23.5 degrees from being straight up and down. Okay, so here's the deal. And what works well in this class, I think, is if we make that clock, okay, we're going to make it a special star we're going to talk about later called Polaris. Okay, so I'm going to move my sun. Okay, here's my sun. And here's the deal. So here's the stick that the Earth is spinning on. Now I'm going to orbit the sun and watch the tilt, okay? So here is the tilt, okay, this way. I'm pointing towards Polaris, okay? Let's see, 12 months, right, to go around once. So let's go in quarters. So 12 months divided by 4 is 3. So 3 months each quarter. So it's going to take me 3 months to go like this. Okay, so check out my tilt though. Okay, and then in another 3 months, I'm going to be over here. Okay, and another 3 months over here. And another 3 months over here. But see how my stick still always points to Polaris. Okay, that's the deal. That tilt, that 23.5-degree angle, always goes like that. So we kind of want to talk about, well, we need to talk about like the whole spring, summer, fall, winter thing. And this is why we have, this tilt is why we have those seasons. Okay, so that tilt is important. So Earth's north axis of rotation always points in the same direction, towards the star Polaris. It's kind of a long story, but in my astronomy class, we kind of get into the fact that actually that our axis of rotation, our north axis of rotation, is not always pointing to Polaris. It's kind of what we call precession, and it kind of is wiggled a little bit, but yeah. So Earth's tilted axis of rotation and the seasons. Okay, so if we go back to this model, this whole sun, and this is the Earth, but actually this is the axis that the Earth is spinning on. When I was right here, actually right here, I was tilted towards Polaris. This actually is June 21st. Okay, this is June 21st. Now, we're going to talk more about the Earth, obviously, and then, so the way this works is, right here is the axis of rotation kind of hidden in here. Okay, so let's find us, because it's all about us. Okay, so here we are, and actually down here in the southern hemisphere, June 21st, it's like I don't know if you want to call it the beginning of summer, but basically it is when we are getting our most direct rays, and they're getting their least direct rays. So when we're in the kind of the dead of summer, they're in the dead of winter. When I say they, I mean the southern hemisphere. Summer, winter. All right. So I can't remember what I put next. Okay. So we said 3 months, right? We said we go 3 months in a quarter circle around in our orbit. 3 months, okay, and then 3 months and 3 months and 3 months. So June plus 3 months is September. June to July, July to August, August to September. Okay. So 3 months we're right here. So right here actually has kind of a neat sort of deal. Right here is what we call one of our 2 equinoxes. So we kind of have, this is the tilted axis of rotation. And notice that the cool thing about this, the sun's light, is basically it's hitting both hemispheres equally. Everybody in the northern hemisphere, everybody in the southern hemisphere, as the Earth spins on this axis, has equal day and nighttime. If I go back to here, oh my gosh. Do you see as the Earth spins here, we have a lot of daylight in June. We have a lot of daylight in June. If you're in the southern hemisphere, not so much. Okay. So we have equal day and equal hours of daylight and nighttime here on equinoxes. Okay. So then to kind of finish that thought, if I go over here, okay, so that would be another 3 months from September. September to October, October, November, November to December. So we're in the month of December here. Actually, can you see where in the northern hemisphere we're tilted away from the sun? And so that is our dead of winter. Okay, we call that the winter solstice. And then 3 months later, we got spring. Okay, so December plus 3 months brings you into March. Okay, that's our another equinox. And then we do it all over again, just like the song says. Trying to see what else I want to do. I think that's a good place to stop for today. And we'll kind of, I'm not done talking about seasons. I have one more slide on seasons, maybe one or a couple. It's a good place to wrap her up. To think about spinning Earth and the orbiting Earth and